All right. We want to talk about sample spaces and probability models. A probability model consists of two parts: a sample space, which is all possible outcomes, with probabilities assigned to each of those outcomes. Okay. And so an obvious one would be dice. If you roll a single die, then you have the options are 1, 2, 3, 4, 5, and 6. And the probability of each of those is 1/6, 1/6, 1/6, 1/6, 1/6, and 1/6. Okay. And so we start seeing all possible outcomes listed here. This is my sample space, and these are my probabilities of each event in my sample space. That's the picture that you want for probability models. But there's a few different types of probability models that we can talk about. The first is when you have an infinite continuous sample space. All right. So this is saying between 0 and 1, everything is equally likely. And so you make this uniform density curve, and the area is 1, so that all the probabilities add up to 1. And you would talk about what's the probability that you're between two values. Okay. The probability at any individual spot comes out to 0 because it's this continuous density curve. And just like the density of a real number line, there's infinite numbers between any two numbers. Like anything has a thickness of 0. Any dot has a thickness of 0. And so the area would be 0 no matter what the height is. Okay. A density curve here, this is a normal density curve that's centered at 0.5, but the area around under it would be 1. And so if it's an infinite continuous sample space, you're stuck using a density curve. Okay. If it's a finite sample space, then we have two sorts of options. If it's finite, it means by definition that it's discrete. And there's two options. One is creating a table. This is something called Benford's law. And I'm going to include a link to a video about Benford's law and the recent election, because people thought that it was detecting fraud in the election, although they weren't using Benford's law appropriately. But if you have large data sets that span different degrees, different powers of 10. So if you have things that are in the tens, the hundreds, the thousands, the 10,000s, the 100,000s, the millions, etc., if you span lots and lots of groups of numbers, so like financial transactions, lots and lots of things fit this, then the first digit is not equally distributed as being 1 through 9. Obviously, the first digit's not 0, because if it started with 0, you would just write the next digit. You would expect these all to be about 11%. But if you look, there's a 30% chance that the first digit's a 1 and a 17% chance that the first digit's 2. There's almost a 50% chance that it starts with a 1 or a 2. That's crazy. It's called Benford's law. I'm sure I'll talk more about it in class. But the outcomes are listed here, and there's a finite number of them, so we can list them all. And the associated probabilities are listed here. So it's the sample space and associated probabilities. The other type is probably what you're most accustomed to in courses that you're studying probability, is equally likely outcomes. This is rolling a dice, flipping a coin. The count of outcomes in group A divided by the total count of outcomes in the sample space. Okay, so the count of outcomes in group A divided by K, which is how many are in your sample space. Okay, so out of a dice, 1 out of 6. But really, what you'll see, there's examples in your textbook that talk about when you roll 2 dice, since there's 6 options on the first die, 6 options on the second die, there's actually 36 total options. We think about getting a sum between 2 and 12, but there's 36 pairings of dice that we need to count individually. Those are my outcomes in my sample space. There's 36 options. It's a 1 and a 1, a 1 and a 2, a 2 and a 1, a 1 and a 3, a 2 and a 2, a 3 and a 1. There's lots and lots of different options. And how many ways can we get a sum of 5 or a sum of 9 or a sum of 7? And it's really good to explore that because it has a finite number of sample spaces, and you can count the number of ways that you can roll any sum or doubles or things like that. Okay. And we'll do an example that deals with that in class as well. So probability models, you have your sample space and your associated probabilities. So up here, my sample space is all that range of numbers. Here, my sample space is that range of numbers, and the probability is listed up here. Okay. Finite you can have discrete sample space, so you have list your discrete outcomes and the associated probabilities, or things can be equally likely. All right, good luck. Farewell.